In this video I'm going to be looking at question 7 of the June 2010 Edexcel FP1 paper. The topic of the question is proof. Now the question gives us a function f of n equal to 2 to the power n plus 6 to the power n, and starts off by asking us to show that f of k plus 1 is 6 f of k minus 4 times 2 to the power k. Having done that, it says hence or otherwise, so this is usually going to be hence, in other words using our result from part A, prove by induction that f of n is divisible by 8 for all values of n that are positive integers. Well, for the first part of the question then we need to start off with the left hand side, f of k plus 1, and that's just a case of substituting into the given formula. So 2 to the power k plus 1 plus 6 to the power k plus 1. That we can write as 2 multiplied by 2 to the power k plus 6 multiplied by 6 to the power k. So that's going to be 6 times f of k. Well, if I just actually write out what f of k is, it's 6 times 2 to the power k plus 6 to the power k. But I'm going to have to subtract from that 4 times 2 to the power k. So that makes the lines move on one from the other. So we've got on the second line rather 2 to the power 2k plus 1. So if I want 6 to the power 2k plus 1, I'm going to have to subtract 4 times that. So I've written 2 to the power k plus kk there instead of 2 to the power k. So what we there have is 6 times f of k and minus 4 times 2 to the power k. In other words, we've proved what we've been asked to. The marking for that, there are 3 marks, a method mark and an accuracy mark or answer mark here, and then finally getting through to the result, another a mark. So 3 marks in total for the question. The next part of the question says we're using that result, move on and do a proof by induction and show it's a divisibility proof. So proof by induction, always these steps that we need to go through. N equal to 1 first of all. When n equals 1, we can see that f of 1 is equal to 2 to the power 1 plus 6 to the power 1, which is 8. So clearly that's divisible by 8, so it's true for n equal to 1 that f of n is divisible by 8. We then assume that it's true for n equal to k. In other words, we can write f of k as 8 multiplied by something. Let's call it p. F of k plus 1, using the formula that we've just worked out, we've shown that f of k plus 1 is 6 f of k minus 4 times 2 to the power k. Well, that's equal to 6 multiplied by f of k minus 4 times 2 multiplied by 2 to the power k minus 1. But I can substitute for f of k this value 8p. So I've then got 6 multiplied by 8p minus 8 times 2 to the k minus 1. So this is equal to 8 times 6p minus 2 to the power k minus 1. And so it's divisible by 8. So f of k plus 1 is divisible by 8 if f of k is divisible by 8. So we've now shown that the formula is, or at least the divisibility is true for n equal to 1, and also true for n equal to k plus 1 if true for n equal to k. So that sort of statement at the end is what the examiners are looking for. So it's therefore true for all n that are in z plus, or positive integers in other words. That's the end of the proof. There were 4 marks available for that. A B1 mark for this first statement of true for n equal to 1. A method mark for using the idea that f of k was equal to 8p. An A mark for getting down to this stage here. And then a final A mark once the proof was complete, and this was a CSO, so correct solution only. So any errors would lose that final mark. That's the end of that question. Further questions and questions to other modules can be found at www.furthermaths.org.uk.